Hello! In this tutorial I will go over various ways to set up your own Mozilla hubs after the sunset of the Mozilla-owned cloud functionality in 2024, along with some resources and tips that make this process easier. I am Marcus Stoffer, researcher and developer at the 4D Research Lab, where we have utilized hubs for many projects and continue to look for further use and development. I will discuss how to set up your own hubs instance, explain the admin and room settings, and finally how to make your own room in the Spoke 3D editor. For this first video, I will start with giving some tips on how to set up your own backend using Google Cloud services. This tutorial is particularly useful for Microsoft Windows users, who will find that the Mozilla tutorials are incomplete, running into many errors. It also includes some supporting software, such as Docker, Kubernetes Lens, which helps observe what is going on inside a Kubernetes cluster, and Helm, which is a package manager for Kubernetes, and very useful in creating and updating the cluster. And before we begin, pay attention to, whatever tutorial you choose, you follow one that includes setting up a persistent volume. Hub's first tutorial, that does not work with the Helm chart, skips this entire part, which causes your data to be wiped whenever you have to reset your cluster. For this part, we will closely follow the tutorial at the link in the description, deploying Community Edition on Google Cloud using the Helm chart. And note that using Google Cloud is only recommended if you have a bigger service you would like to run, as the pricing isn't very suitable for smaller services. Notably, the minimum persistent volume size is 1 terabyte, which makes the costs at least €250 a month. So now let's get started. As a first step, we can make a new Gmail or use an existing one. We will also use this address for a mailing function for hubs, so consider whether it is worth making a specific new address for this application. And you might need to fill in some info to verify, like a recovery email or your phone number. So now that we have our Gmail account, with it we can go to the Google Cloud platform at cloud.google.com. Note that you will have $300 or around €280 worth of free credits, so for testing purposes you do not have to spend anything. So after filling in your personal information, you have gained access to the Google Cloud dashboard. Here you can check your free trial credits as well. Now we can go to the page for the Kubernetes Engine API. On this page, click the button to enable the API. You can then check the notifications in the top right for progress on this action, which should be finished within minutes. In general, we only need to access 3 things here: the Kubernetes Engine API, the SQL database, and the file store capability. Although the Kubernetes dashboard can be overwhelming, we mostly look at the 2 pages here, Clusters and Overview, where we can later see the results of what we did in CMD. If we now go back to the tutorial, you can see that the second requirement is installing Helm. So to install Helm, we will be choosing Chocolatey here, a package manager for Windows. From the Helm website, there's a link to Chocolatey, and then click Try it now on the top right. From individual installation, we can copy-paste the command that appears here in Windows PowerShell. There is also a CMD command on Chocolatey's site, but it gives my machine a security error, so I'll do it this way. And in my case, I already have this installed, so the script will not continue, but this means that the script succeeded. Then use the command from the Helm website, choco install Kubernetes Helm. If you see this purple message, you are not yet running PowerShell or CMD as an administrator, so exit for now and restart as administrator. Now Helm should have installed correctly. If you type Helm after this install, a bunch of commands will pop up. Then we need the Google Cloud CLI, which you can download from here. You can also find this site by searching for Install Google CLI. You can either use the CLI installer as a download or run the PowerShell command given here. Once the installer finished successfully, just typing gcloud in CMD or PowerShell should give you a list of commands. Now our job is to make sure gcloud is up to date and has the kubectl component installed. So for me the first time it failed, probably because there was an older install present. I had some trouble getting the kubectl install to work right away. If you run into this kind of trouble, run gcloud components update. And if that doesn't work, run gcloud components reinstall. It now says everything is up to date, so we're good to go. Now you can run gcloud components install kubectl and answer yes by typing the letter Y to continue. Now I do want to make sure that my current context is the correct one, so I will be running the command described under step 5 here. And then in any case, run the commands for the firewall rules. And we do this because the Kubernetes cluster will run audio, video and multiplayer components parallel to each other. And the opening of these ports prevents users encountering issues in latency, desyncing or not hearing sound at all. And then just to show how this logging method looks like. But actually we can download Kubernetes Lens, which visualizes the same information in a useful and clear way. So with Lens installed and opened, we can click Browse your local catalog, then click the cluster we made, which will start with GKE, and then contain your project name, and then look at pods under workloads. These pods will not be the ones we will be using later on, but here we can click any pod and look at its logs. This will be essential for troubleshooting later on. So for the next part, we will first need to download the files that go along with this tutorial. Go to the top of the page, and above the header introducing Helm, the link Hub's CE Helm Chart links to the GitHub with the files. If you're comfortable with Git, feel free to clone this, or otherwise just download the zip file and unzip it somewhere. I recommend making a folder at your C drive, because the short path will be useful later on. In this new folder, you can first open the render Helm file in a text editor. I use Visual Studio Code here. You can edit the database user and password to your liking. Also remember that we will need these when setting up the SQL account later. And that's it for the render Helm file for now. Let's first go to the Google Cloud Console and make an SQL instance there. From the sidebar, we can select SQL to reach the main screen. Choose to create a PostgreSQL instance. You can randomly generate this password. It's not the user password that we saw in the render Helm script. It's the master password of the instance and isn't necessary now. Double check that you're using Postgres 12, because this is the version that the Hub's codebase expects. Choose Enterprise, select Sandbox, Single Zone and a single CPU to lower the costs for now. Finally, under Connections, we need to set a private IP. Click Default Network, then Set Up Connection, enable the API, and then select Use an automatically allocated IP range. Then we're done here, so click Continue and wait for it to finish. When it finishes, you can click Create Instance, and this will also take a few minutes. The next step when we look at the Hubs tutorial is creating a certificate manager. If you have ever seen a website give a blank screen with the warning that the site is not secure, it's because its certificates have failed a check. Especially for internal references, we want our hubs domain to have valid certificates, and the hubs tutorial has a good solution for this. We will also need our command prompt again. To install the cert manager, first create a new namespace using kubectl create ns security. Ignore the stuff popping up on my screen, this is still from the Kubernetes logging we did before. Then use the commands given in the tutorial one by one. Helm repo add jetstack with the URL after it, then Helm repo update, and then the last command. Make sure you write this in a single sentence without the slashes. If you make a mistake, no problem, you can use Helm uninstall cert manager to uninstall and try the command again. A successful result is when CMD says cert manager has been deployed successfully. And it then asks us to set up a cluster issuer, which we will do now. We can create a new file, any file, and name it clusterissuer.yaml. If it is still interpreted as a text or the original file type, in Windows Explorer, click View, then Show, and then check File Name Extensions, and make sure it is just .yaml instead of .yaml.something else. And inside this file, we can copy the script from the hubs tutorial, and then just edit the email address to your email. Now, in Windows Explorer, copy the directory that you have your .yaml files in, and going back to command prompt, run cd, and then paste the path you have just copied. Then we can run kubectl apply -f cluster-issuer.yaml, and it successfully created our cluster issuer. For the next part, we will be using Amazon Web Services for setting up a domain name and a simple email service for our hubs. Go to console.aws.amazon.com and make an account. Once you're in, you can use the search bar at the top to search for Route 53. For the domain name and records, this dashboard is what we will be using. In the sidebar on the left, find Registered Domains and click Register on the top right. Here you can type any kind of URL you want. Be aware that common names are probably taken, and that endings other than .com might be more expensive. And then finish your purchase. You can see in the blue notification that AWS is working on your domain, so let's come back to it later. Also keep an eye on your email that you filled in for the AWS account, because a verification is essential to be trusted for AWS services. For the other component we need, you can search Simple Email Service in the search bar at the top of the page. This service is easy to set up, but it does require you to briefly describe your use case for it. Firstly, add the admin email that you are using for hubs to Configuration, Identities. Choosing the email option and then verify via the email that you've been sent. Here I still get an error of the domain name hubstesting.com not being verified, visible in the logs for the reticulum pod. It's an error regarding Phoenix. The Phoenix WebSocket has to do with the email communication of hubs. So then, using the same method, Configuration Identities, add your domain name using the domain option. This will then require verification via the email that you gave for your AWS account, in case it's different from the email that you're using for hubs. The last step for the mail service is getting the SMTP credentials. While still in Amazon Simple Email Service, click the menu above Configuration, SMTP Settings. Then, first copy the SMTP endpoint, visible here, to the render Helm script in your hubs folder. Afterwards, click Create SMTP Credentials. You can create a username here, and double check that the permissions policies are like this. in the next screen you see your SMTP credentials. These only appear now, so definitely copy them. The username and password both go to your render Helm script. Username to SMTP_user and password to SMTP_pass. And then we are all set regarding the mail service. To summarize, if you later still see issues in Lens related to the unverified identity, check the error and depending on what it says, go to the AWS console and check your mailing address and the domain name via SES configuration identities. And check your account email for any verification links that you might have missed. Now let's try building our first version of hubs. The next part causes the most issues on a Windows machine because the render Helm sh script runs differently, causing errors. To prepare for this step, we need the Docker software, with which we will make a so-called Dockerfile that will run the script in the correct way. Let's continue to the Docker website and download the software by going to Products, then Docker Desktop, and hit Download for Windows. When we have installed and opened Docker, the application will open, looking something like this. But in fact, as long as it's running in the background, it will already provide us what we need. To test, you can type Docker in your command prompt, and if Docker is online, it will give you its list of commands. To get the Docker file, we will base this on a GitHub solution found at the relevant link to the GitHub of Hubs Foundation in the description. These 12 lines of code can be copy-pasted to our own text file. As long as the file name is Dockerfile with a capital D, and it is in the same directory of our Hubs values file, it will work. Comparing our Dockerfile for the Helm Chart way of building, there are a few differences. First, make sure to change render HCCE to render helm.sh on lines 8 and 12. Secondly, the command requires your Hubs domain and admin email. Make sure that these are both within the 2 quotes at the end. Now, using the commands from the GitHub post, we can run this Docker file. Make sure you change to the correct directory using the cd command, followed by the directory path. Then use docker build.-t hubs ce builder latest. The first time you run this Docker file, this will take a short while. Once it has finished, you can use docker run -rm-it-v followed by the path of your directory. Note that the formatting of this path can look strange to you if you are used to the path starting with c:/. This path begins with /c/. Finally, add the Docker build from the previous command, hubs ce builder latest. Once we get our output, check for any errors. The most common here is that PEMJWK is not installed, which causes an error in the security keys. To solve this, run npm install -g pem-jwk and run the second Docker command again. Now we can make a copy of the values GCP YAML and for example call it values my-gke YAML. This is the file which we will be building hubs from. On the right side of the screen, I opened the config file that was created by the render Helm script. We can already fill in some of the attributes in our values file. Copy the attributes for config's data and paste them under the command get the following from render Helm. Then copy the TLS, CRT and key and paste them under the default cert data. Make sure to fix any tabs to align everything correctly, to prevent the build attempt later from failing because of a read error. We are now ready to work towards the first creation of our hubs. Go into your values file again and change the bits between curly brackets to your info, the domain name and your hub's admin email. After doing this, you do not need to change it anywhere else in the YAML, as it will be filled in by those two attributes. Double check everything in render helm sh is filled in. Note that Node, Guardian and Phoenix can be any random combination like what you see here, but might glitch when using any special characters, so limit it to letters and numbers. Sketchfab and Tenor are not necessary, but fun to implement if you want at a later time. We will again build the Dockerfile and run render helm through it. Then copy the details from the created config YAML to your values YAML. Now we're ready to build. Since you already should have a CE chart folder, you can change the directory to it using the cd command. Then use the command kubectl create ns for namespace and then the name you want to give it. Now we can use the command from the tutorial. If you are in the hubs chart directory, you can just use helm install mos -f, the name of your values YAML, a dot, -- namespace, followed by the name you just created. And a successful deploy will give the following message. After every install, for upgrades it's not necessary, we need to watch what our new external IP address will be. Use the command that the output gives you. kubectl get -- namespace, svc for service, -w and the name of the load balancer, which is haproxy-lb. If the external IP is still loading, it will refresh and show here whenever it's ready, so wait a moment. We can then copy this external IP and go to our domain at AWS, Route 53. Going to hosted zones, we will be adding some records using the orange button, Create Record. We will put this external IP as the value. Using Add Another Record, we can easily create the other three. For those we need to change the record name, so subdomain will be replaced with assets, stream and CORS. For all of these you can just change the value to the external IP. When those records have been made, it will be possible to go to this website that you made. It will take a few minutes for the records to update though. Now if everything worked correctly, you will find a security risk warning when going to your domain. This is because, even though Cert Manager might be working, there is a component that will default to the wrong certificate. To change this, we will go to the Mozilla Hubs folder, then the charts folder, haproxy, templates and edit this deployment YAML. There is a lot here we don't need to touch, but here under containers, arguments, you will see a default SSL certificate. Just add a hash in front of the entire line to comment it out. Finally, use the upgrade command, helm upgrade mos -f, the values YAML name, dot -n and your namespace name. After fixing both the mail verification and default certificate, we should see no further errors. If a change still doesn't come online, either delete a particular pod in Lens, as it automatically will come back online using the new settings, or uninstall the Helm instance with helm uninstall mos -- namespace, and reinstall using the install command. Now our hubs is online. I logged in through a properly received link in the admin email, and here we can see that the security certificate checks out. However, we do not yet have a persistent volume set up. To add the persistent volume that we need, go back to the Google Cloud Console, search for File Store, and click Enable to enable the Cloud File Store API. To explain the difference with the SQL service, the database that Hubs uses is in SQL, and this also has a smaller size limit. FileStore instead has a volume, a kind of hard drive where data can be written to from the database. Once the API is enabled, we can create a FileStore instance. Click Create Instance and edit the settings as follows. Give it an ID, and change the service tier settings to the cheapest possible amount, basic HDD. Select region and zone and make sure both match what you have used earlier in the tutorial. Set network to default, and finally give it a file share name, which we will also need for the values YAML, and then hit create. We can then go back to SQL and fill in the private IP address into external database host. Now the Postgres bouncer service will connect to Cloud SQL instead of spinning up an extra pod inside the Kubernetes cluster. This allows for persistent data that is not removed when the cluster is reset. Then go to the values YAML and add 2 lines at the bottom of it, PG-SQL and enabled false. This makes sure that there is no SQL connection pod. In the meantime, your file store instance will have come online, so we can scroll up in the values file and edit some more attributes. First, copy the IP part of this address and paste it in IP. Then, the latter part is the share name. Paste it in both volume name and the last part of the volume handle. Finally, use the location and instance name to fill in the rest of the volume handle. Because we changed the render Helm settings as well, we will rerun the script to make sure the keys and secrets are matching. And when reinstalling, I run into the error that HA proxy couldn't be found. We can see in the logs from Lens, especially for PG Bouncer, which takes care of connecting to the database, that the login credentials aren't valid. This is correct because we have yet to create a user and database with these credentials. As before, cd to the folder and run gcloud SQL users create, followed by the DB user in your values, then -- instance is your SQL instance name, and then finish with -- password is your DB pass in your values YAML. If there is still a missing API, like this one, you can press Y to approve the enable. Then, if this succeeds, run gcloud SQL databases, create reddb, and this is the DB name in the values YAML, followed by -- instance is your SQL instance name. And then we are set. Now perform a Helm upgrade, and it brought the HA proxy service back online. Note that I have to reapply the IP addresses to root 53 because of the reinstall earlier. We are now finished with the backend and will soon move on to the fun part of creating rooms and adjusting settings on our hubs. Remember that if you still run into any errors, which is very understandable due to the complexity of the Helm Chart, Kubernetes and Google Cloud services, look at Lens for any errors in the logs of Reticulum or PG Bouncer pods, look at any errors in the developer tools of your browsers, and visit the Hub's Foundation Discord or GitHub for any further questions. Most issues are well known, and people experienced with those issues are ready to help you get your hubs online. I will show you an example of how your hubs looks like after setting up. You will see in your default hubs the scene editor, which you can use to make your own scenes. How to do this is covered in another video, so check that out if you are interested. Next to it are the admin settings, only visible if you're logged in with an admin account. Note that some things are currently unavailable, such as the avatars and scenes, and the guides and documentation. The documentation, however, can be found at the Hub's Foundation website. Choosing the options under Customize the look of your hub will lead you to the same place as the Setup, App Settings or Brand menu. Here you can modify your starting page with text and some images. Then, under Pending or Approved Scenes, you can approve and see scenes you made in the scene editor. It is important to note the difference between a scene and a room in hubs. A scene is your project as it is in Spoke, and remains untouched and unique until you consciously copy or change it. Rooms are like chat rooms based on a scene, and can have independent settings and user-placed objects, after which the link to the room should be kept, as it is not visible or accessible in the admin settings. Other settings include the content of the mail that your hubs will send you to log in. Be aware of a possible bug here with using a line break in this text, as it might cause your entire landing page to have no images or custom brand. Furthermore, new accounts are made anonymous using the randomized account ID. This means that if you would want to make someone admin, make sure to ask any admin candidates for their sign-up email. If there is a match when you fill in this email here, the account ID is uniquely theirs and you can safely give them admin rights. Finally, let's go over how to set a default room and some basic room settings. In Approved Scenes, edit any of your scenes and add a new tag. Then simply change this tag to Default. After doing this, the Create Room button on the landing page will automatically grab this scene. If there are multiple default ones, it will take a random one of those. Then, when in the room, going to Room Info and Settings and clicking Edit on the top right will allow you to change the room settings. There are some important things here, for example the maximum room size, whether the room is listed on the home page through a tile and thumbnail, and further general permissions. Permissions go over creation and moving of objects, creating cameras to take in-scene photos with, pin objects so they can't be moved, and create drawings or emojis and allow flying. Flying is then enabled by pressing G, but be aware that this allows users to also clip through the boundaries of your scene. The transition of hubs after Mozilla dropped it is a work in progress, and currently, assets and documentations aren't available. If you are able to help with these issues and others, feel free to join the Hubs Foundation Discord, and you can also stay up to date on any progress at the same time. Then I hope this tutorial was useful to you, and leave any questions in the comments. And please watch the other tutorials on Mozilla Hubs on the 4D Research Lab channel, which cover all the things you can do in the scene editor and inside a room.